Hi, my name is Nishal, and this is my final presentation of the robotic arm project. The goal of my project was to create a robotic arm that uses computer vision to detect a block and calculate the necessary angles to get to that block using inverse kinematics and pick up that block consistently. Throughout this project, I used a combination of hardware software to achieve these results, and in this presentation, I will walk you through the design, implementation, testing, and results of my project. Okay, let's start with an overview of the design. The robotic arm consists of several components. Let's start with this one. This is the enclosure that I created in SolidWorks, and here you can see a suction cup under here. Actually, I have four of these under each corner here, and then the last one is there. So this is added later on because my arm kept tipping over whenever it was trying to reach blocks that were further away. Whenever it was trying to go there, the enclosure would just tip over. So adding these made it more stable. Here we can start with the motors. Here under there, I have the base motor. This is the shoulder motor, and this is the elbow, wrist, and the gripper. And the last one that I have that I didn't use is a rotation of the actual gripper. This would rotate the gripper like this, but I didn't actually have any use for that because I was just using this block, which doesn't really rotate anywhere, so it's fine to grab it anyway. So I didn't really use it. It's not connected to anything. So if you see a dangling wire, it is from that. I didn't use that specific motor. But other than that, all of the other motors from top to bottom are then connected to a small servo controller that I have here. I actually used this servo controller for other projects as well, so I just used it here. So these are connected to these motors because these motors are pretty heavy and they cannot be powered just from Raspberry Pi. So here I have them connected to a 5200 milliamp hour LiPo battery. I actually don't have it connected right now, but it is where I would connect it, and that power would come through the controller to the motors, and then also the controller is connected to the Raspberry Pi, which essentially connects everything together from camera to all of these motors. And here, let's talk about the block that I used. Here you can see the Aruco marker that I have as well. So this is I have added it with the duct tape, but essentially whenever I place it anywhere in front of the arm, the camera just detects the marker and sees how far it is. It calculates the X, Y, and Z in the 3D space. And about how the X, Y, and Z is calculated, I will explain that in a bit. I'll go through all of my codes. But before then, you can see how the white ribbon is coming from camera to the Raspberry Pi. That's essentially how the camera is connected to my Raspberry Pi. But with that X, Y, and Z, I use that with another Python code that I have to calculate the angles for each of the motors that I have here. All of these motors will get their own individual angles calculated specifically for them, which will be able to pick up the block directly like this, and whenever it picks it up, I have made it so it goes to the left. I had a little bucket there, but I don't have it anymore, but essentially it will leave it there. And I also have a mic that I added at the end just to make it more interesting, and a speaker here. This allowed me to do voice controlling. I will also include that in my GitHub, so you can check it out. So this is the overview of the overall project that I have. Now I will go into in depth on how everything works. So before starting, I just want to go through and go to my report and give some context. So here on keyboard controlled arm .py, essentially this was for my preliminary testing part of it, where I tested my motors on my arm with WSD, like all of these letters from my keyboard. I just wanted to see the physical limits of each of the motors, how much they could go without hitting themselves, and these were the results that I found. I just wanted to give a context before starting because these angles will be coming in most of these other programs as well, so a bit of context from where I found these angles. This is where it came from. So starting off from the beginning, I have arm.py, which is the main file that integrates all of the other smaller files all together. So here I start with a, under the main function here, I have the while loop, which constantly runs and tries to hear for the trigger word, which in my case is activate now. And I listen to this through the microphone using another file that I have here that I've made. This basically uses the speech recognition library to try to understand whatever the user is saying, and whenever it recognizes that it says the trigger word, which is activate now, the if statement here lets it advance, where the speak text, this is another file that I have here. It is from audiout.py. Again, all of these things are inside of my GitHub, so you can check them all out. Here I use eSpeak to say this sentence out loud through the speaker that I have connected. It says, please wait, the arm is activating. So that lets me know that the arm hears the activate now command and now is gonna start. So activate now.
Please wait, the arm is activating.
Okay, so when it says please wait, the arm is activating, it goes next to the main function up here, which uses the camera file that I have. This one. I introduced the Aruco library of OpenCV, and I use that to detect the marker, and that whenever the marker is detected, it goes and uses estimate pose single markers to essentially find the XYZ coordinates, and then this converts it to inches and then sends it back over to my arm.py file again. Here, after getting X, Y, and Z coordinates, I send it to get motor angles. This is inside of another file of mine inside of calculate angles for. So this is the file that I use on my simpler version of inverse kinematic in, but this is way too long and way too complicated of a code to just explain it in this 10-minute video. But inside of my blog post for the report, I have explained it very thoroughly with a example that I do a walkthrough of. So please check it out. But yeah, also I have the code in my GitHub if you want to check it out. After I get the angles from get motor angles, I send each of those angles for each of those motors to the move motor file that I have. It basically uses the Adafruit servo kit, like the library of servos, to just move the, so I just get like kit.servo, and then I give the motor number from my servo controller that I have, and then that essentially lets me move the motor to that specific angle. After that, the arm essentially goes and picks it up. I do the pickup function, which essentially grabs the object and then place it is another function inside of my move motor file. This is a hard-coded place where I wanted the object to be placed into. And after it places it, it resets the motor, essentially comes back to the idle position. And after all of those are done, it says I am ready to go again. And then I can keep doing this over and over, trying out different locations and different angles, and it works perfectly. I have the video on my blog post at the end, and yeah, you can check it out. Thank you.
I am ready to go again.